Welcome to the course on Python for data analytics, machine learning and generative AI. This session introduces data visualization not as an auxiliary skill but as a core analytical practice.
This built-in visualization tool enables learners to move seamlessly from data manipulation to visual interpretation within a single programming environment. This session will cover importing pandas, line plot, which is a default pandas plot, and cumulative visual effect using area plot, categorical aggregation using bar plot, distribution analysis using histogram, relationship between variables using scatter plot, spread and outliers using box plot, smooth distribution using KDE plot, and dense data visualization using hex bin plot.
By the end of this session, you will have developed a structured understanding of data visualization as an analytical practice rather than a mechanical task.
Pandas plotting is tightly integrated with Matplotlib, which means every plot generated through Pandas is ultimately rendered using Matplotlib's engine. This design allows analysts to move seamlessly from data manipulation to visualization without switching libraries. The focus here is clarity, speed, and exploratory insight rather than heavy customization. We begin by importing Pandas, which is used for data handling, and Matplotlib, which serves as the underlying plotting backend. Although Pandas can generate plots directly, Matplotlib is still required to display them. This combination ensures flexibility while keeping the syntax concise. Once imported, we are ready to visualize data directly from the data frame.
So, let's open Jupyter Notebook and start writing some Python code together and bring the concept of visualization to life.
In the first step, we import the most important library for data analysis in Python called Pandas. Pandas help us work with datasets in the form of tables similar to Excel sheets. Here, we write import pandas as PD. This means we are importing the pandas library and we are giving a short alias name PD. Using PD makes our code shorter and easier to write. Instead of typing pandas.read_CSV off, we can simply write pd.read_CSV off. This is a standard practice in almost all Python data science projects. Now that pandas is imported, we will load the data set. Here we use the function pd.read_CSV of tips.csv. Here, read_CSV of reads a CSV file, which is separated value file. Tips.csv is the dataset file name. We store this dataset inside a variable called tips. So now tips contains the full dataset as a data frame. We also use tips.headoff to show the first 5 rows of the dataset so that we can quickly preview what kind of data we are working with. This is a very important step because before plotting anything, we should confirm the column names, the data format, and whether the data set is loaded correctly. The line plot is one of the most commonly used visualizations in Pandas. By calling the plot_of method on a data frame or series, Pandas automatically generates a line chart. This type of plot is ideal for observing trends, patterns, or changes across an index, such as time or ordered categories. It is especially effective for time series analysis and sequential data interpretation. Next, we create our first visualization using the line plot. Tips of total_bill, tip dot plot of. This means we are selecting 2 numeric columns, total_bill and tip. And then we are plotting them as line chart. By default, Pandas plots the value using the index on the x-axis. So the x-axis becomes row numbers 0, 1, 2, 3 and so on. We also customize the plot using title is equal to line plot of total bill and tip, x label is equal to index, y label is equal to amount, in the form of dollars, and grid is equal to true. Finally, plot.showOff displays the plot. This plot is useful when you want to see how values change across observations. But since restaurant bills are not time series data, the line plot is mainly for demonstration. Area plots are generated using plot.areaof and are useful for comparing cumulative values over time. The filled regions help emphasize magnitude and contribution across categories. Area plots are often used in business analytics to show growth patterns or market share evolution. Stacking multiple columns allows direct comparison of contributions within a whole. Now we create an area plot using tips of total bills, tip dot plot dot area of. The area plot is similar to a line plot, but the area under the line is filled with color. This creates a stronger visual impact and makes it easier to compare the magnitude. We also set alpha is equal to 0.4. Alpha controls transparency. So the fill will not be too dark and we can still see overlapping values. This plot is useful when you want to show cumulative trends or compare how two variables contribute visually. Bar plots in Pandas are created using the plot.barof function. Each bar represents a category and its height reflects the corresponding value. This visualization is particularly useful for comparing quantities across discrete groups, such as sales by region or counts by category. Pandas automatically handle labeling, making bar charts quick to generate and easy to interpret. Now we move to bar plots, which are excellent for comparing categories. Here we calculate the average tip for each day using tips.group by day and tip.meanof. Group by of day groups all rows based on the day column. Tip selects the tip column only. Dot meanof calculates the average tip for each day. Then we plot it using plot.barof. So this bar chart clearly shows which day has the highest average tip and which has the lowest. Now we create a stacked bar chart to compare two categories at once, the day and time, such as lunch and dinner. We write tips.groupby of day, time and tips.meanof.unstacked or plot.bar of stacked is equal to true. First here, we try to group by day and time. Then we calculate mean tip. Next, unstack of converts the second category time into separate columns. Finally, stacked is equal to true stacks the bars on top of each other. This is extremely useful when you want to compare not only totals but also contributions from subgroups. Histograms in Pandas are created using plot.histof. They show how numerical data is distributed across different ranges or bins. This visualization helps identify skewness, concentration of values, and potential outliers. Histograms are essential during exploratory data analysis, especially before applying statistical models. Next, we analyze distribution using a histogram. Tips of total bill dot plot dot histof bins is equal to 20. A histogram shows how frequently values occur. The parameter bins is equal to 20 means the data is divided into 20 ranges. More bins means more detail. Fewer bins means smoother grouping. This plot helps us answer questions like, are most bills small or large? Is the data skewed? Are there extreme values? Scatter plots in Pandas are created using plot.scatteroff. Each point represents an observation plotted using two numerical variables. This visualization is ideal for identifying relationships, correlations, or clusters within the data. Scatter plots are frequently used as a preliminary step before regression or predictive modeling. Now we explore relationships using scatter plots by writing tips.plot.scatter of x is equal to total bill and y is equal to tip. Here, which means x-axis is equal to total bill and y-axis is equal to tip. Each dot represents one customer record. Scatter plots are excellent for showing correlation. Now we enhance the scatter plot by adding color encoding. By writing tips.plot.scatter of x is equal to total bill, y is equal to tip and c is equal to tips of size, c map is equal to viridis. Here, c is equal to tips of size means the color of each dot depends on group size. C map is equal to viridis is a color map that smoothly changes color in density. So now the scatter plot shows two relationships at once, total bill versus tips, and how group size influences the points. This is very powerful for multivariable visualization. Now we use a box plot to analyze spread and detect outliers. Tips of total bill dot plot dot box of. The box plot shows the median value, the quartiles, and any outliers beyond the normal range. Outliers appear as dots outside the whiskers. This is useful because restaurant bills may have extreme values. Now we compare total bills across days using tips.boxplot of column is equal to total underscore bill, by days, grid is equal to true. This creates multiple box plots, one for each day. So we can compare which day has higher typical. So we can compare which day has higher typical bills, which day has more variability, and which day has more outliers. We also import Matplotlib and call plot.title of, plot.subtitle of to remove extra title, and plot.showOff to display the chart. Kernel density estimation, commonly known as KDE, is an advanced method used to visualize how data values are distributed. Unlike histograms, KDE produces a smooth probability density curve, making it easier to identify patterns and trends within the data. This technique is particularly useful for understanding the overall shape of the data distribution while minimizing the impact of noise. Now we write tips of total bill dot plot dot KDE of. KDE plot is like a smooth version of a histogram. Instead of bars, it shows a curve representing the probability density. This makes it easier to visually understand the shape of the distribution, especially when the data is continuous. We also label the x-axis as total bill and display the plot. Now we create a hex bin plot, which is used when scatter plots become too crowded. Tips.plot.hexbin, x is equal to total bin, y is equal to tip, grid size is equal to 25, C map is equal to oranges. Hexbin plots divide the space into hexagonal bins. Instead of plotting individual points, it shows density. So, darker regions represents more points and lighter regions represents fewer points. This is extremely useful for large data sets where scatter plots becomes messy. Although Pandas emphasizes simplicity, it also supports basic customization such as titles, axis labels, colors, and figure size. These options improve readability without requiring deep Matplotlib knowledge. For advanced styling, Pandas plots can be further modified using Matplotlib commands. This layered approach balances ease of use with professional presentation quality. Now we focus on plot customization. Tips of total underscore bill, tip dot plot of style is equal to hyphen, figure size is equal to 10, 5, grid is equal to true. Here, style is equal to hyphen makes the line solid. Figure 10, 5 controls the plot size. Grid is equal to true adds grid line for readability. We also add title, X label, and Y label. Customizations improve clarity and make your visualizations professional. Finally, we create a summary table for students. This is extremely useful for revision. We create a data frame containing plot type, Pandas method, and the best use case. Line plot is best for trends, bar plot is best for categorical comparison, histogram is best for distribution, scatter is best for relationships, box is best for outliers, KDE is best for smooth distribution, hexbin is best for dense scattered data. Pandas visualization acts as a bridge between raw data and analytical insight. While it may be replacing specialized libraries like Seaborn or Plotly, it excels in fast, reliable exploratory analysis. For data scientists and business analysts, Pandas plots often serve as the first visual checkpoint before deeper modeling or storytelling. Mastering this toolkit significantly improves analytical fluency. Thank you.